This is Mr. Martin. This video is for Pre-Calc Honors. It's from the Limits Worksheet Day 5, and this is going to be the solution for number 17. So we can see we have this strange pieced together graph here, and it has a domain that goes from -1 to +2, and we want to find all these limits and answer some other questions. So the first thing we want to do is find the limit as x approaches 0 from the left. So as I approach 0 from the left, that means I'm coming this way. And as I approach 0 from the left, the y value is approaching 0. Alright, and as I approach x from the right, I'm also approaching 0. And this idea of continuity that we're going to talk more about, if I approach a point from the left and the right and I get the same value, then the limit as I approach that value without specifying the left and the right, that means we're approaching at both sides at the same time, is also 0. Alright, moving on to the next one. We've got the limit as x approaches 1 from the negative side. So that means I'm approaching 1 from this side. So we're going to be approaching 1. Now as I approach 1 from the right side, I'm on this little piece of the graph that's on the x-axis. So as I approach 1 from the right side, my y value is approaching 0. Now since these two values are different, this notation here, the limit as I approach 1 from both sides at the same time, does not exist. These two have to be the same in order for this to exist. Alright, moving on to part G, we have the limit as x approaches 2 from the left. So now we're approaching 2 from the left, so that's going to approach a y value of 0. Now as we approach 2 from the right, there's no graph to the right of 2. It's not defined there, so this limit does not exist. And then since the limit from the left and the right aren't the same, this does not exist as well. Alright, so our next part here is the value of the function at 0. So even though the curve's the limit is 0 as I approach 0, the value of the function is defined to be 1. Alright, and then on the interval from -1 to 1, f of x is discontinuous at x equals, so -1 to 1. So we're looking from here to here. Okay, discontinuous means that we're going to have jumps or gaps or holes. So in this case we see we have a hole here. So in order for it to be continuous, so continuity at a point means that the limit as x approaches some value of f of x is the same as the function evaluated at that point. So the limit as we approach 0 is 0. That's these two up here, or part C. But the value of the function at 0 is 1. So on the interval from -1 to 1, f of x is discontinuous at a value of x is equal to 0. So this definition of continuity has to do with continuity at a point. We'll also talk about continuity of a function over a certain interval. So keep that in mind as well. Alright, so if you have any other questions about that, let me know, and we'll see you next time.